In everyday life, people use their hands to comprehend information and the world around them. This behavior also occurs when perceiving a complex visualization of data, such as a network visualization. However, little to no studies have investigated how hand interactions could potentially affect how people comprehend a network visualization. We sought to investigate through physicalization, when our data is fully fabricated into the real world, how hand interactions could affect how we comprehend the data. We became interested in physicalization due to the inherent haptic properties that physicalizations bring to a network visualization, and how that could come to play with hand interactions. We first explored how to design and fabricate network physicalizations effectively. We started by developing software to create the layout of the network, followed by rendering and fabricating the networks with a 3D printer, to try to design networks to work visually as well as haptically for the people interacting with the network. After refining the design, we began to formulate the research questions we wanted to explore around network physicalizations. This began with comprehension, so could interacting with a physicalization affect the amount of time and accuracy of comprehending it? User experience, so whether participants interacting with the network self-reported their experiences as different or not. And interaction, so how do participants interact with networks under certain conditions? To explore these research questions, we developed a study with 4 conditions: haptic only, graphical only, visual only, and visual haptic. For haptic only, participants were blindfolded and could only perceive the network with their hands. For graphical only, participants could only view the network on a screen but couldn't move their hands. For visual only, participants could only view a physicalization of the network in front of them and not move their hands. For visual haptic, participants could view and interact with a physicalization with their hands. Our apparatus consisted of 2 pads that the participant had to place their hands on between trials, and a foot pedal that they were required to press after having an answer for a given network-centric question. From our results, unsurprisingly, haptic only did worse in respect to time and error. For user experience, visual haptic was preferred for counting the number of triangles in the network, self-reported by participants in between conditions. In addition, participants felt that visual haptic was more accurate than graphical only. In ranking the different conditions at the end of the study, participants additionally preferred visual haptic for comprehension and accuracy. For interaction, we found that participants exhibited a variety of exploratory procedures deriving from past literature in human haptics. From video recordings of the visual haptic and haptic-only conditions, we were able to code the exploratory procedures that participants performed. We found that participants performed different exploratory procedures based on the tasks that they were required to complete. The codebook used to code the procedures as well as additional information can be found on the Open Science framework. For future work, we are particularly interested in fabricating the networks through a 3D layout to see if there are any significant changes to how people explore and interact with the data, as well as exploring new aesthetic criteria that may aid participants in navigating network physicalizations. Thank you for listening.